Hello, chemistry students. So this video today is going to cover the Bohr model, the modified Bohr, and Lewis dot structure. And so as of right now, the story so far with our atomic model is Rutherford has determined that there is a small, dense center of the atom that he called the nucleus. It is positively charged and it contains the protons and the neutrons, which is the most of the mass of the atom. J.J. Thomson discovered the negatively charged electron, and the negatively charged electron is determined to be outside of the nucleus, with most of the atom being empty space. And so Bohr came along and organized things a little bit more. He said that there was a nucleus, and yes, in the nucleus were our protons and our neutrons. So P positive, N 0. Yes, you need to write these in your nucleus. And so then he said that the electrons circled around the nucleus. They orbited the nucleus, much like a planet orbits the sun. And so he called these rings orbitals. We're going to call them energy levels because that's what they are. They're not really orbitals. We're going to get to that later. But there's energy levels. And so the further out from the nucleus, the more energy levels you have. We're going to do a Bohr model for calcium. And so when we look at calcium, calcium has an atomic number of 20 and a relative mass of 40.0. And so by looking at this, we are going to have our protons, our neutrons, and our electrons. The atomic number is 20, so that means I'll have 20 protons and I'll have 20 electrons. The mass is 40. 40 minus 20 means I will have 20 neutrons. I'm going to write that in my nucleus that I have 20 protons and 20 neutrons. And so now to show my electrons, I'm going to show them as dots on my ring. Now in physical science, you learned that these are on opposite sides of the ring, and that's because like charges repel. So that's absolutely correct. They do repel. But since this is a model, it has limitations like all models. And to help set us up for success later on, we are going to go ahead and always pair up our electrons unless there's only one electron. And so because of that repulsive force, my first energy level is so small that it can only hold 2 electrons before it pushes the third electron to the next energy level. And so for now, we will learn a little bit later this week that this isn't quite the case, but for now, the rule that we're going to follow is the first energy level always holds 2, and every energy level after that holds 8. So I've got 2 valence electrons here, and so that means that I still need 18 total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not quite done yet. So I need another energy level. So that was 10. (11, 12, 13, 14, 15, 16, 17, 18. I need one more energy level. Let's see if I can make it fit here. There we go. It's close enough. So that was 18, 19, and 20. And so with this, that's a big boy. And so this is kind of tedious. It's kind of time-consuming and tedious. Draw these circles. It takes up a lot of space. It's really hard to keep it neat and organized. And so instead of doing the Bohr model in this class from this point on, we are going to draw a modified Bohr. So we're still going to include all the important parts of the Bohr model. We're just going to make it more convenient for us. And so with that, we're still going to include our symbol. We're going to include our nucleus. We're going to include the number of protons inside the nucleus and the number of neutrons inside the nucleus. But now, instead of drawing these circles, if you notice, if you were to put lines here, it looks kind of like a ladder. So that's really all we're going to focus on. Here I had 1, 2, 3, 4 energy levels. And so I'm going to draw that as 1, 2, 3, 4 rungs of a ladder. It just makes it easier. It's much more condensed, much more concise. It's a lot easier to pay attention to. Also, counting dots is kind of difficult. And so instead of drawing dots on these, I'm going to go ahead and just put how many there are. In my first energy level, I have 2 electrons. In my second energy level, I have 8 electrons. My third energy level, 8 electrons. And finally, my fourth energy level, I have 2 electrons. Now, something I failed to mention was that these outermost electrons, so the electrons on the outermost energy level. And remember, we said that these rings are our energy level. The electrons on the outermost energy level, so the electrons that are the furthest from the nucleus, are referred to as your valence electrons. So those are our valence electrons. I'm going to write that again down here a little bit neater. And so in this case, I have 2 valence electrons. That's important because sometimes we're not going to care about how many electrons are on each energy level. We're going to get to a point where we focus on bonding. And when we focus on bonding, it's the valence electrons that are really important to bonding. And so for that, we show a Lewis dot structure. And so with our Lewis dot structure, we're going to simplify it even more. In this case, I'm still going to have my symbol because I still need to know that it's calcium. But I'm not going to draw all of these electrons. I'm going to draw just the valence. And so there are 2 valence. Again, in physical science, you may have learned that you draw them on opposite sides of the symbol. And that worked for physical science. But for us, we're going to get in the good habits for when we do bonding, that we're going to show them as pairs. Another rule that we have is you're going to pretend that there's an imaginary box surrounding your symbol. And the reason why we have this imaginary box is because when we put electrons around it for our Lewis dot, only 2 electrons can fit per side of the box. And so with that, when I put my electrons, I'm going to put 1, 2 electrons. Calcium, that doesn't really matter too much, but when we get to things like chlorine has 7 valence electrons. And so, with my imaginary box, so you don't have to draw this box, I'm just drawing it so that way you understand what I'm talking about. Chlorine has 7 valence electrons. If you draw the modified Bohr and you draw all the electrons it has 7 valence electrons because it is 17 total. And so we're going to draw this as 1, 2, put your pairs together, then move on. Only 2 can fit per side of the box. So 2, 3, 4, 5, 6, 7. So draw them as pairs on each side of the box before you move on to the next side, and only 2 electrons can fit per side of the box. So this has been modified Bohr, Bohr model, and Lewis dot structure.